Hello and welcome to AzureMonk.com. This is the Kubernetes Explained in Plain English series. And in this video, we'll be explaining pods in plain English with the help of Phippy and her friends. This video series is meant to take you from zero to a solid understanding of Kubernetes. We will also have practice labs that you can follow along step by step right from your web browser. First things first, Z wondered, why are we starting off with pods? Because she was just a beginner, she knew nothing about master nodes, worker nodes, or even the Kubernetes architecture. Aunt Phippy smiled and replied, "Don't worry, Z. This series doesn't require you to have any Kubernetes experience. In the Kubernetes world, almost everything revolves around pods. Pods is the most basic execution unit, or it is the smallest and simplest unit in the Kubernetes object model. So if you get the basics right, you'll build a foundation that is strong. And then in the further upcoming videos, we'll layer on with more complex topics and then go over the Kubernetes architecture and the rest of the components." Alright, so let's get started. You would have all heard of the benefits of running containers in a microservices world. We're not going to get into that. So as you might have already heard, Kubernetes is an open source system for automating deployment, scaling, and management of your containerized applications. Z wondered, if pods are the most basic unit in Kubernetes, where are the containers? Well, a container or containers are wrapped in a layer of abstraction called pods. Let's start off with why it's called pods. It's called pods because a group of whales is called a pod. It goes with the whale theme for the Docker containers. In general, pods are not like your virtual machines where they are durable. Pods are to be treated as disposable and replaceable. In other words, if one pod dies and gets replaced by another pod, it shouldn't affect the functioning of the application. You can think of pods more like a cattle and virtual machine as a pet. Z wondered, if pods are a wrapper around a set of containers, can she put all her web containers and database containers inside of a single pod? Well, no. The idea behind pods is to represent a single instance of an application. So in this case, having the web and the database in the same pod is considered an anti-pattern. The web containers would be in its own pods and the database containers would be in its own pods independently. Z hurriedly placed all the web containers in a single pod and all the database containers in a single pod. "Well, not so fast, Z," said Aunt Phippy. "Remember, you only want to be placing one single instance of a container inside of a pod. Each pod gets its own IP address. This helps in scaling independently. Now let's say the load on the web components increase, you can independently scale the web components without really scaling the database components. This level of flexibility gives you a huge advantage when designing microservices-based architecture." But Z wondered, but this sounds like regular Docker containers. What is the advantage of having a pod if it's recommended to have only one container per pod? Well, the recommendation is not to have just one container per pod, although in most cases that is going to hold true. However, having said that, there could be scenarios where you have a supporting or what we call sidecar containers placed alongside an application container inside the same pod. Z immediately pounced with the question, like what? Well, let's say you have a log aggregator. You want to have a sidecar container like a log shipping container, which is always close to the application container so that the log shipping container can send the logs from the application container to the log aggregator. Now, the advantage of placing them in the same pod is that they share the same network space. If you remember from before, pods get an IP address and not the container itself. So they can communicate with each other using localhost. They also share the same storage and volumes mounted on the pods. One other advantage of running it inside of a pod is that it provides all the benefits of self-healing, scheduling, etc., which we'll cover in the later videos. Alright, great. But where do these pods run? These pods run on nodes, which could be physical machines or virtual machines. We'll cover all about nodes in the later video, but for now, all we need to do is all containers inside of a pod is always co-hosted and co-located on the same machine. What we mean by that is a single pod cannot traverse multiple nodes. Z was in a hurry to get to the practice labs. But before we jump into the practice labs, we need to understand that there are two broad ways you can create Kubernetes objects: imperative and declarative. For example, consider this analogy. Let's say Z wants to get to the zoo from her home and reach the zoo at 2 p.m. for a special line safari. Using imperative way, we would say, Z, walk straight for 3 miles, then take a right at the corner. From there, take an express train, get off the train at the zoo station, and take a cab to get inside the zoo, because that's the only way you're going to make it to the safari on time. With the imperative way, we need to define each of these steps, but we also need to have a good understanding of the current state in order to make a decision. For example, if you're already way ahead of time, you don't need to take the express train. So you as a user need to have a clear understanding of the current state of the environment to run the imperative commands to get to your desired state. With the declarative way, you don't really care about how you get there, but all you care about is the end state. Z should be at the zoo at 2 p.m. That's it. We let Kubernetes do the magic behind to make the current state match the desired state. Now, Kubernetes does this by continuously watching the current state and the desired state and matches the state as soon as it sees a change. Awesome. We are now ready to get our hands dirty. Click on the link below in the description, which will take you to a pre-baked Kubernetes Sandbox environment directly from your web browser, where you don't have to set up a cluster or an environment. This is an awesome tool created by Ben Hall called Katacoda. This particular lab uses Kubernetes version 1.18 or above. This is important because some of the commands we're going to be running today have changed the behavior in version 1.18. kubectl is a command line tool that we use to interface with our Kubernetes cluster. You'll learn a lot about kubectl in the upcoming videos. This is going to be your companion when you're working with Kubernetes. First, let's verify the version of Kubernetes by running the following command: kubectl -version, and look for the server object and look for the git version. In my case, it shows version 1.18, which is what we want. Great, we have the right version. Let's first create a pod using the imperative way. You would do that by using kubectl run, give it a name, and we provide an image for the container. In this case, I'm going to be using Nginx as an image. Well, that's it. Now you have your pod created, which has a container running inside it. You can also run the kubectl get -pods to check the status of your pods. If you add the --watch switch, it will continuously monitor for change in the status. But what if you want to do it the declarative way? Now, you can create a YAML file from the scratch, but I would recommend use this shortcut for your YAML creation. Run the kubectl run with the name and an image, and then add the --dry-run tag and set it to client. Now, what does this mean? When we set the dry run to client, it does not really create an object yet, but it just prints out the YAML that will be used to create it. Now, if we run this, we get the output. But we want to be able to edit it, so let's take that output into a YAML file. We do that by appending the file name at the end of the command. Now that we have the file, let's edit that in the editor. You can see that there are 4 main components here: the kind, the API version, the metadata, and the spec. Now, if you're wondering how to remember the kind and the API version for all of the Kubernetes objects, don't worry, you don't have to. Here's a quick shortcut. You can always run kubectl -explain and the object that you would want to give the info for. In this case, pods. And if you scroll up, we would see the kind and the API version. Don't worry too much about it right now. The next piece is the metadata, where we define attributes on the name and the labels of the pod itself. Labels are extremely important in Kubernetes, and we'll talk about labels in a future video. But for now, let's understand that it's a key value pair to distinguish objects. The next section is the spec, where we define the actual parameters of the container itself: the container image, the container name, etc. I can also have another supporting or sidecar container like we discussed in the same pod, and I can do that by adding that onto here. Remember that YAML is all about indentation, so make sure you have that right. Great. Now that we have this YAML file, we need to ask Kubernetes to apply this. The way we would do that is using kubectl apply space f and the file name.yaml. There you go. That's it. We now have a pod with 2 containers defined inside of a YAML file. Now, let's go ahead and delete the pod using kubectl space delete space pod and the pod name. Let's check the status of the running pods again by running kubectl get pods. We now see that the pods have been deleted. Z wondered, if Kubernetes is self-healing, shouldn't it bring the pods back automatically? And Phippy replied, yes Z, it is self-healing, but that's accomplished using replica sets and deployments, which is why you would almost never want to create a pod directly in your production environment. We'll talk all about replica sets and deployments in the next upcoming videos. Thank you for watching. I'll see you again in the next video.